This is Kathy and Esther, and this is the LFU for base jump STL week 8 milestones. So, overview of our project is to develop an LFU algorithm for integrating into base jump STL to replace the current LRU algorithm. And we're attempting right now to create the LFU algorithm.
So our progress from the last 2 weeks are that we implemented the LFU frequency matrix and the RTL for LFU, and then we modified the BSG cache. So then it uses the new LFU policy instead of the LRU. And then we're also running simulations and synthesis for the LFU module in BSG cache. And then we modified the frequency matrix to solve some bugs. And then we also are trying to compare different cache simulators to potentially use for software implementation. And then one of the main things we do was the debugging.
So originally our LFU design had, I think it was 1 bit per way, or I think it was the log of the frequency width size. So it didn't have enough space to store the actual number of frequency. So we basically modified our ways to be the frequency width times the log of the ways to account for the size.
And then for the cache simulator, we found a software implementation in Python where we get to set the memory size, cache size, block size, mapping and replacement policy and writing policy. And so the second image is a picture of what it looks like when we run it. So you see that there are a couple of commands that you can use. We could do random read, random write, or we could also read from a certain address or write to a certain address. So we're planning, and then at the end, it outputs the stats, so then we know how the performance is. And then we're planning to use this to compare the results of different patterns with LRU and LFU. And the next steps are to develop a detailed test on LRU and LFU using the cache simulator and then document the results. We're also planning to synthesize the RTL and compare the PPA with the original LRU BSG cache. And we also plan to add moving window to the RTL of the LFU policy. And that's it. Thank you.